This is lesson 4.2 in your notes packet. This is pages 5 through 7, one-step inequalities and words for inequalities. One-step inequalities, we're going to solving inequalities is just like solving equations. We're going to go ahead, drop a line down our equal sign. I have x plus 3. My goal is still to get the x by itself. So to move the 3, I'm going to do a minus 3 on both sides. X is less than 4, and that's my final answer. In the next one, go ahead, drop your line down. X minus 10 is greater than 15. I'm going to add 10 to both sides, leaving me with x is greater than 25. The next example, I'm going to subtract 5 on both sides. X is less than or equal to 4. In the next example, add 7 to both sides. X is less than 11. You'll notice so far that all of these were addition and subtraction. That's because the only one thing that happens is a slight change when we are actually working with multiplying and dividing with negatives. So if we just have positive, 5x is greater than 25. These are stuck together with multiplication, so we'll use division to undo it. These match, so I cross them off. X is greater than 5. In the next example, we have a negative 5 stuck to the x. We are going to go ahead and divide by a negative 5. Unfortunately, when you divide by a negative, though, because of our integer rules, we're going to flip the whole thing around with the inequality. So what we actually have to do is flip our inequality symbol once we multiply or divide by a negative. So 25 divided by a negative 5 is a negative 5. The reason being, in this case, if you were to plug in a value that would be true, x is less than negative 5, and plug it in here, this would work out. But if you plugged in a value where x was greater than negative 5, for example, 0, you would have 0 is greater than 25, and that doesn't work. So the except for one thing happens. When you multiply or divide by a negative, you need to flip the inequality symbol. So in this next example, I have x divided by 3 is greater than or equal to 6. To undo divide by 3, I'm going to times by 3. I am multiplying by a positive, so I get to leave my symbol exactly the way it is. And 6 times 3 is not 6. It is, in fact, 18. In the next example, I'm going to multiply by a negative 3 on both sides. Because I am multiplying by a negative 3, I need to flip my inequality sign, and I get x is now less than or equal to a negative 18. One other funny thing that happens here, for us, we always want our x to actually be on the left-hand side because that's the only way that we can actually graph our inequality accurately. So one of the things that I would have you do is I would have you actually take this part, not with the x, just the 4 and the symbol, and I would have you move it. So I'm going to have you just move the 4 over here, and then I want you to look at your symbol. It's pointing to the 4 and it's opening to the x plus 2. So when we move the 4, we also want to move the symbol. It still needs to point to the 4 and still needs to open to the x plus 2. Once we move it, we can kind of just cross it off and act like it was never on that side and go ahead and solve. So I'm going to subtract 2 on both sides. Adding and subtracting is exactly the same. X is greater than 2. In the next one, we're going to go ahead and move this 3 over. So I'm going to bring it over here. My symbol is opening to the 3 and pointing to the x over 4. So I need to make sure it opens to my 3 and points to the x over 4. And then I can kind of cross this off. X divided by 4, I'm going to times by 4 on both sides. X is less than 12. So that step is mainly so that we'd actually be able to accurately graph it. We want to keep our x on the left-hand side. So down here, we're going to do a couple solving ones and which numbers would be solutions. X divided by 4 is less than 4. We're going to times by 4 on both sides. X is less than 16. So there are a bunch of different solutions here. It's not just 16 would work for us. We actually need any number that's less than 16 would make this true. So numbers less than 16 here are 4 and 8 and 12. In this next example, we're going to go ahead and subtract 3 on both sides. And we're going to get x is greater than or equal to 12. Numbers greater than or equal to 12 are just 12. In this one, we want to move our 19 because we want our x on the left side. Opens to the 19, points to the x plus 4. cross off the old. We're going to go ahead and subtract 4 on both sides, and we get x is less than 15. So any numbers less than 15 on here would include 4 and 14. For number 4, we're going to move the 12 over, and we're going to go ahead and make sure it opens to the 12, points to the 6x. To get x by itself, I'm dividing by 6, and I get x is less than or equal to 2, because 12 divided by 6 is 2. Numbers here less than or equal to 2 are 2 and 1. For the next one, I'm going to go ahead and divide through by 7 on both sides. X is less than or equal to 3. So I have 3 and 2 and 1 would all work. In this last example, I'm going to subtract the 5. This would have been one of our rule busters because the 5 is out front and we know it's positive because it's not marked otherwise. X is less than 2, and the only one up here is a 1. Other than how we say the symbol, there are some other words. So when we talk about less than, we're going to see fewer than. We might see the word under. We might see the word below. We might see the phrase smaller than. We might even see the words lower than. And you can have all sorts of different takes and things on these words, but those are kind of the majority. With greater than symbols, we're going to see words like above, a phrase like more than, larger than, exceeds, or is over. This is not an exhaustive list. These are just some examples. When we talk about less than or equal to, we might see the word like at most. We might see a word like budget, a maximum, not above, not or no bigger than. You might see does not exceed, and you might see no more than. Again, not an exhaustive list, but those are some of the words. When you see greater than or equal to, you'll see words like at least. You'll see minimum. You might see the phrase no fewer than. You might see not under, no less than, and not smaller than. Again, not an exhaustive list. Anytime I come across these words in the word problems, I always think about if I were to see the phrase, I have at least $20 in my wallet, that means that there's $20 or more. So I'm talking about $20 is equal to or greater than because I'm looking at more. So I'm constantly going back to that concept as I'm looking at all of these. So the first one, X is not more than 13. X, not more than. So it's going to be $13 or less in my wallet. So less than or equal to would be our correct symbol. X is more than 3. X more than 3. Just X is greater than. X is at most 5. So there's $5 or less in my wallet. So less than or equal to 5. X is fewer than 10. So X is less than 10. 6 is not less than X. So we'd say 6 is greater than or equal to X. But if you remember, we want to make sure that we write this with the X first. So it's pointing to the X and opening to the 6. So we want to rewrite this one. X is not less than 8. So it means not less than 8, so greater than, but it could also be 8. X is not more than 5, so less than or equal to 5. X is at least 20, greater than or equal to 20. X is no more than 4. X is less than or equal to 4. 10 is less than X. Again, we want to rewrite this one. X on the left. X is opening to the X and pointing to the 10. X is less than 8. And X is more than 2. That wraps it up for lesson 4.2, Inequalities, One Step, and Intro to Words.